The ocean, a symbol of life and tranquility. But what if I told you that millions of years ago it transformed into a merciless machine of destruction, a disaster so catastrophic that it unleashed a deadly cascade of events, wiping out life on an unimaginable scale? What was this ancient disaster? How did it weaponize the oceans, turning them into agents of mass extinction? And could it happen again? Brace yourself as we unravel the terrifying story of the ancient ocean's transformation, a tale of death, resilience, and lessons for the modern world. To understand how the ocean became a destructive force, we first need to explore its delicate balance. The oceans were the heart of Earth's ecosystems, regulating climate, supporting marine life, and maintaining the oxygen-carbon dioxide cycle. Marine food chains, from tiny plankton to massive marine reptiles, were interconnected and relied on stable conditions. For millions of years, Earth's oceans supported a vast diversity of life, serving as a cradle for evolution. They acted as a thermal regulator, absorbing and redistributing heat across the planet. Marine ecosystems thrived, providing habitats and resources for countless species. However, beneath this serene surface lay a system highly sensitive to change. Long before the Great Dying, smaller events hinted at the fragility of the oceans. Episodes of volcanic activity, asteroid impacts, and shifting continents occasionally disrupted marine ecosystems. Each disturbance left scars, but also showed how resilient life could be, until a perfect storm of conditions arose. For millions of years, Earth's climate and ocean chemistry remained relatively stable. But this balance was fragile. A single catastrophic event could and did tip it into chaos. The first major disaster that weaponized the oceans occurred 252 million years ago during the Permian-Triassic extinction, also known as the Great Dying. This event wiped out over 90% of marine species and 70% of terrestrial species, making it the most severe extinction event in Earth's history. Over a million years, massive volcanic eruptions in present-day Siberia released staggering amounts of carbon dioxide and sulfur dioxide into the atmosphere. Global temperatures soared by up to 10 degrees Celsius, 18 degrees Fahrenheit, causing widespread wildfires and acid rain that devastated ecosystems on land and sea alike. These eruptions didn't just change the air, they fundamentally altered the oceans. Ash and gases from the eruptions created an atmospheric veil that temporarily blocked sunlight, disrupting photosynthesis and causing food chain collapses. The volcanic emissions created a cascade of effects. Excess carbon dioxide, CO2 dissolved into the oceans, turning the water acidic and disrupting marine life. Oxygen depletion. Warmer waters hold less oxygen, leading to vast dead zones where marine organisms suffocated. Hydrogen sulfide, the deadliest weapon with oxygen levels plummeting, anaerobic bacteria flourished, releasing hydrogen sulfide, H2S, a toxic gas. H2S poisoned marine and terrestrial life and even bubbled into the atmosphere, depleting the ozone layer and exposing the planet to harmful UV radiation. This chain reaction left the oceans nearly lifeless, with massive die-offs of corals, fish, and other marine organisms. The balance of the oceans tipped irreversibly for millennia, reshaping Earth's biosphere. The toxic oceans didn't spare terrestrial ecosystems. Forests burned under acid rain, and the sky darkened as ash and greenhouse gases filled the atmosphere. Herbivores starved as plant life withered, and predators followed suit. Entire ecosystems vanished, leaving behind barren landscapes. The increased heat from volcanic activity and greenhouse gases led to super hurricanes, known as hypercanes, with winds exceeding 500 miles per hour. These storms churned the seas, spreading destruction far and wide, uprooting ecosystems and altering coastlines. Methane hydrate eruptions. Frozen methane buried under the seafloor was destabilized by warming temperatures. Methane explosions triggered underwater landslides, releasing more greenhouse gases and amplifying global warming in a feedback loop. Massive undersea earthquakes and landslides generated colossal tsunamis, devastating coastal ecosystems. These waves swept away entire marine habitats, accelerating the extinction spiral. The disruption of thermal gradients caused major ocean currents, such as upwelling systems, to collapse. This halted nutrient circulation, further starving marine ecosystems. Ozone depletion and radiation surges. Hydrogen sulfide release significantly damaged the ozone layer. Harmful UV radiation penetrated the atmosphere, mutating DNA and further stressing life. Each of these phenomena further destabilized the planet, creating a self-reinforcing cycle of destruction. Rising carbon dioxide levels are causing ocean acidification, mirroring the conditions of the Permian-Triassic extinction. Dead zones are appearing in modern oceans due to pollution and fertilizer runoff, leading to oxygen depletion. Coral bleaching events driven by rising sea temperatures are threatening entire ecosystems. Climate change accelerators. Melting ice caps are releasing methane stored in permafrost, a potential trigger for another methane eruption. Increasing temperatures and extreme weather events are eerily similar to the conditions that created hurricanes and tsunamis in the past. Unlike the natural disasters of the past, today's changes are driven by human activity, making the situation even more unpredictable. Overfishing, deforestation, and industrial emissions exacerbate the fragility of ocean systems. The ancient ocean's transformation was a warning, a reminder of how delicate our planet's systems are. The disaster that turned the ancient ocean into a machine of destruction holds critical lessons for us today. The importance of balance. The ancient oceans thrived when their chemistry and temperature were stable. Preserving this balance is essential for modern ecosystems. The forces unleashed by the Great Dying remind us that nature is both powerful and fragile. It can take millions of years to recover from a single catastrophic event. Unlike the volcanic eruptions of the past, today's disruptions are caused by us, but this also means we have the power to prevent another oceanic apocalypse. Sustainable practices, renewable energy adoption, and global cooperation are essential to mitigating current threats. The ancient ocean's tale is one of destruction, but it's also a story of resilience. Life returned to the seas, evolving into the incredible diversity we see today. After millions of years, coral reefs formed, marine mammals flourished, and new ecosystems thrived, demonstrating the regenerative power of nature. Now it's up to us to protect this legacy. By learning from the past, we can ensure that our oceans remain a force of life, not destruction. Thank you for diving deep with us into this incredible story. If you enjoyed this journey through time, don't forget to like, subscribe, and hit that bell for more explorations of Earth's hidden history. Until next time, stay curious.